every unit test that you take is going to have a multiple choice section followed by a free response section. Why? Because the Regents exam has a multiple choice section followed by a free response section. Right? So the idea is that we're going to learn a great deal about algebra in this course. We're going to get a good, solid understanding of the concepts, but then also be prepared to take a unit test, but also the Regents exam at the end of the year. All right. For these kind of questions, you need to be able to identify what property you're dealing with based on a symbolic expression. The trick, though, has really less to do with rote calculation than it has to do with really thinking about what the action is. All right, so it's more of a verb than a noun. So what I'm doing here, I'm going to turn my pen on. I'm going to go with blue for those keeping score at home. Oh man, look at that! Look how thick that marker is. It's ridiculous. All right, nicer. All right, so we're adding opposites. All right, so we're adding opposites. That's not bad when you think of it that way. So now you just got to think about what property means the same thing as adding opposites. Well, I'll start with the one that has addition in it. So let's get rid of these two. Oh, sorry. I missed that. It had addition in it also. But I can get rid of the multiplicative inverse because it doesn't involve addition. All right. So what's another way of saying opposites?
Inverse.
Inverse, yeah. Yeah, inverses are opposites of one another. All right. So if you focused on the opposite part, you might have actually narrowed it down a little bit more initially because you would have eliminated choices 2 and 4. And then you would just focus on the fact that you're adding. But it would end up being choice 1 just because you knew what the term inverse meant. Right, really in reverse. Right, but inverse is such an important term. And it's also a confusing term in math because it's a catch-all term. The idea that inverse means opposite, it's fine, but then if you think of it that way, it's like, all right, well, if it means opposite, why don't we just use the word opposite? Additive opposites. All right, it doesn't quite roll off the tongue, but there are so many things in math that are referred to as inverses that you'll be like, wait, is that the same thing? If you always have it in your mind that its base definition is opposite, then you'll be fine. So if I want to cancel, for example, I want to cancel an expression that's being multiplied. I would do that through division, right? I'm using the inverse operation, right? Whatever the inverse operation would be, it would be defined as the opposite of the given operation. So I'm starting off with multiplication, so I use the inverse, the opposite of that, which would be division. All right, so it's always going to boil down that way. Whatever you're doing initially, do the opposite of it. All right. What's going on in number 2? It's definitely addition. So we're adding in reverse order. There's like a lag with my pen. It's crazy. All right, so we're adding in reverse order. All right, and you see what I'm doing here. I'm taking what's written there and I'm just writing it in simple terms. Normal people speak. All right, the way you would explain it if you had a 4th grader at home. All right, brother, sister, I'm assuming. Cousin, maybe. And the reason I say 4th grade is because my son came home with his homework last night. You know what was on it? Calculus, exactly. You know what? No, that'll be his 9th grade homework, I think. because his 4th grade homework was the commutative property of addition and additive inverse. Basically, it was this. So, did you do this in 4th grade? I mean, it's Common Core, so probably some variation of it. So, but the idea is, and so what I've been doing with him is saying, like, listen, you need to know the notation, but you also need to interpret it. What language do you speak? English. No, what language do you speak? I don't know what the hell you're saying. I'm asking you, how do you speak to other people? Do you speak like I speak? No, because I only, I'm me, you know? You have your own dialect. The way you speak to other people is based on your own experiences. So use those experiences to translate this into the way that you would say it. All right, so if you would not think add in reverse order, then don't write add in reverse order. Write it the way that you would think it. All right? If you would say add in opposite order, add backwards, whatever, just translate it to your own way of thinking. All right, that makes all the difference in understanding math language. All right, and if you make that adjustment early on, I promise you, if you're the kind of person that hated math, that'll change. That'll change very quickly. All right, what's going on in number 3?
Multiplication.
Multiplication in reverse. Just making shorthanded notes, so I'm just going to abbreviate. All right, so we decided that it was the commutative property of addition for number 2 because we were adding, so here I guess it would obviously, and I don't think it's insulting to say obviously, be the commutative property of multiplication. Now, I commute to work on a daily basis. That means I go to work and I come back from work. That's how I remember commutative property. Right? I mean, that's a complete lie. I mean, I remember commutative property because I've known it for like 35 years. But if I were just learning it today, that's how I would remember it. All right. So you're commuting to school on a bus, you're going there, and you're coming back. All right, that's what's happening with these operations. All right, what about number 4?
Multiplication.
Multiplication. So let's go boop and boom. Well, yeah, inverse, because very nicely, they threw this bad boy in there for us. All right, and very nicely, they threw this bad boy in there. Okay, so we're using the choices to help us answer the question. In number 4, multiplication property of 0. Well, I don't see a 0 in there anywhere. So, well, it's not that. I suppose A could be equal to 0, but if you divide 1 by 0 on your calculator, you're going to have a problem. All right, so you're actually multiplying opposites. Bless you.
Thank you.
All right, because you're taking A and multiplying it by its opposite. Opposites are inverses. But reciprocal is what you would get if you take a number and flip it over. All right, so if I have 2/3, flip it over, I get 3/2. The only thing that becomes weird is when you think about a whole number. Like the reciprocal of 5 is what?
1/5.
1/5.
Yeah, 1/5.
And that's because there's that understood 1 underneath the 5. All right. Every whole number could be represented as a fraction. That's why whole numbers, integers, are part of the rational number set. All right. Which of the following properties is demonstrated by the equation below? Distributive, yeah. that one, I honestly, I don't know that we need to make notes because we've already kind of established what inverse property looks like, what commutative property looks like. Distributive property was the first choice. I guess we could have got to associative property, but we never really got there before we settled on distributive, because each one of these terms in the binomial, each one of them got the 9, right? Each one of them got the 9 through multiplication. They were each distributed a 9, right? So there's no reason to think it's anything else. Associative property is really just talking about regrouping and still getting equality. All right, is that happening here? Yeah, so that's true. Multiplication property of 0. Multiply any number by 0 and you get 0. True?
Yeah.
Multiplicative identity. Multiply by 1. You don't change the identity of the original number. True. Additive identity. Result is equal to 0. Yeah, that's false. This one should be actually what? Inverse.
Yeah.
All right, now this right here happens to be the identity. This is the additive identity. And let me just very quickly show you what that would look like in an appropriate form. If you were to have something like B plus that additive identity, the result would be B. The idea is that an identity through whatever operation will not change the original quantity. All right? So that's the case here.